Hello, we are Team 1. I'll go and start by introducing ourselves. I'm Isaiah.
I'm Aaliyah.
I'm Connor.
I'm Nagabhargav.
I'm Binh.
And obviously the prompt was, how can we reduce the power output used by the average American household per year? And so first thing we asked ourselves, hey, what actually appliance uses the most energy? And it turns out it's the HVAC system. In fact, it uses about 50% of the entire heating, uses about the 50% of the entire energy usage in an average household per year. And for the most part, Americans aren't even in the household. It turns out they're at work, they're at school, and it's a lot of wasted energy being put into use when no one's even there. It's not being used whatsoever. I'll give it to Ben now.
Okay, so why can't we just turn the AC off when you leave the house? Like, imagine you live in the very hottest day of the summer, and then when you leave your house, you turn the AC off. I would tell you, like, the AC system, it can help you to remove the humidity inside the house. But if you turn it off, the humid inside your house will increase a lot. And it's really, really bad for your home furnishing and the house itself. Also, like, imagine you leave your house in the early morning for work, and then 8 hours later you get home, and then you want to turn on the AC again, and it takes you longer to reach the comfortable temperature. And it's a nasty experience, right? And also, if you just keep turn it on, turn it off, turn it on, turn it off, I think it's really hard for the AC system. And then also on the market nowadays, we have some products. You have some products to solve the problem. Like, one of them is like the HVAC zone dampers. There's a downside. The big downside of this solution is very high cost if you want to install it, because when you do that, we have to adding onto the air duct system a series of plates that can be opened and closed to regulate the air flow for the heating and cooling for each room. And this process, it takes very long time, and also it costs you a lot of money. Also, you can see right here, the average cost to install an HVAC zone system is between from 1,700 to 4,500. Okay, so what's the solution?
IntelliVent, it is a solution. So it is our product which was mainly developed based on 3 sensors which are integrated with Raspberry Pi microcontroller. So what we did is we just use an IR sensor, and we just gonna pick hotspots in a particular room. Suppose let's take an example of hallway, just taking as couch as a hotspot, or else and 2 to 3 more hotspots where we frequently move. And when this IR sensor, when it sends the infrared rays, and when an obstacle or a human just walks around, when it gets back that ray reflected back to its receiver, then it sends some feedback to a microcontroller, feedback to a servo motor, which we are just fixing to our AC vents. So whenever it gets a feedback saying, okay, there is some person, I just got that feedback, and then it turns on the vent so that the rooms get cooled down. And whenever there is no obstacle for the IRS, then it says, okay, there is no one, you can just turn off the vent. So we are just opening and closing the vents basically. So even in this situation, we are not closing vents completely, we are just leaving it for 75% or 73%. It's because to maintain the pressure evenly in the whole our duct. So the main reason, if we are just not making this balance, then we are just messing up with the whole HVAC system. And also we have included a DHT11 sensor, which is basically a temperature and humidity sensor, we just set a low and high bound temperatures by default, so that whenever if there are no one in house, and if the temperature raises up, and suppose if the person is he went to his work and there are no one at home for a couple of hours, and if the home gets too hot, then we can't do anything, right? So this sensor, it just gives the feedback, okay, it's too hot, you should turn on your AC now. And then the vents goes up and room gets cooled down, and we set a time delay for 5 minutes. So after 5 minutes, it gets back to its normal state.
All right, some benefits to our product, the IntelliVent, is that it is mainly for new homeowners who are looking for a cheap and low-cost solution. There will be more on prices a little bit later, but another part of it is that we don't actually include it to separate thermostats or separate zones within the house. It is just simply connected to the vent, so it's like an extension of sorts, and it projects about 10% energy just on the fan for the HVAC system.
We're projecting a cost of $40 per vent, and this is working in tandem with a variable speed HVAC system, so that you don't have to run it on full power to get the air to the places you need. Our customer base, as she said, was new house owners looking for a very cheap solution to use less energy on their HVAC fan. And I got some numbers for houses being built in the USA right now from the Census Bureau, and taking that in proportion to the market value of the variable speed HVAC fans, which is a requirement to use the product to its fullest potential, I got 26,420 newly completed homes just in the year we're projecting it would take to launch our product, taking in time for research and like market analysis. And that would be our customer base for most of the time, to be new houses as they're being built, look for a solution. And as we grow larger, we would look at retrofits, but those would not be a core market because the variable speed fans are a newer technology that is being adopted in the US. They are not as common as the single speed AC that is common in older houses.
So the graph on the right, it shows the amount of carbon dioxide and other emissions that are being let out into our air in the US by homeowners. And as you can see, that there is the direct emissions, indirect, and total emissions. The direct emissions since 1990 has been on a decrease by 2%. And then the indirect emissions, which is where the HVAC systems and all that lie, it increases from 1990 to 2007 before going on a decrease. And recently in 2021, it decreased over just about 4% from its initial value in 1990. So with that, with this product, we're expecting a launch for about 6 months to 1 year, and that's for testing and research purposes. And then if it gets bigger or larger, we could expand it to hotels and apartments and other big complexes that would need a cheaper solution for these types of vents and easy installation.
All right, so far that's all we have for today. We'll go ahead and after this presentation try to show you a live demo real quick. But everyone stay with me. A greener world, one vent at a time. Let's see if...
Where's the mouse?
Okay, so basically what's going to happen is it's not detecting anything right now. It's just like no one's in front of it. And so it's completely just closed right now. But then the moment I move my hand right in front of it, it then opens the vent, which allows air to flow properly. And then there's also, we have a temperature, constantly checking the temperature and the humidity. If it goes above 27 degrees Celsius, it'll end up opening the vent again, just so it's not using extra energy later down the road in order to keep or cool down the system for now. Besides that, I think that's everything we have. Thank you for coming.
Judges, you guys have an opportunity to ask questions for 1 minute.
One quick question. So you mentioned the investment cost, capital cost, right? So it's very low. So it's $40 per vent. Do you guys consider in terms of maintenance costs over the life of it, especially with the proximity sensors that they wear out, reliability of sensors you use? Was that taken into consideration?
Roughly, I know from personal experience that they last probably about maybe 2 years, but they're pretty easily to replace. So, if I remember correctly, it ended up costing us about an extra $10 to get them replaced.
Yeah.
So if you it'd be just an extra $10 to get the actual IR sensor replaced in terms of that, and then also the temperature sensor just in case. Does that answer your question?
How do you expect to get power to the vents? And is it
In this case, so the whole idea is you have a central Raspberry Pi, or oh, I see what you mean. Okay. So the idea is that it's not in this demonstration right now, but we would just have it connected to either to a separate power supply, whether it just be battery that can be replaced, or just wired into the wall as well. Most likely, that was just a battery that you can just plug in, and it should just work right there, and it should be able to connect to the Raspberry Pi with a Bluetooth chip as well, which is what was included to the $40 as well.
So you said this is just connected to the vent, correct?
Yes, it's like a vent cover almost.
So it doesn't have anything to do with the generator itself?
Correct.
Okay, because I'm wondering what's going to happen if you close the vent. If you detect a hot spot in one room, you close the vent, all that air is just going to be pushed into the next room because it's not going to slow down the generation of the cold air.
So because it's at like a 23-degree angle, it's not like air how should I say this? It's not like it's stopped completely entirely. There is still some air getting into it. So because if actually were to close the vents entirely, you would actually create that pressure vacuum, and it would cause that kind of issue. But just being able to open it just slightly at its base will kind of prevent that issue from a sudden rush of just cold air or hot air, depending on what it is, into the
What I mean is if you don't slow down the generation of the cold air, it's going to keep using the same amount of electricity, and all you're going to do is be moving, one room's going to be extremely cold, and the other one will be warmer because you have the vent closed.
Yeah.
Yeah. So in this situation, as he told, we are not closing vent completely, so even the cooler air comes out.
He's not exactly asking that. He's asking more
Right. How does this affect the actual HVAC system and the volume of air it's flowing?
Yeah.
The intention
Are you saving electricity?
The intention with the product was to leave your unit going at a lower volume, just at a normal time, so that, and you use the gates to essentially get the air to where it needs to go while still using a lower amount of air, just as like a lower base setting instead of trying to adjust it on the fly.
And unfortunately, we didn't have time to implement this, but it was trying to implement maybe an app to control the temperature from your phone if things are getting too cold or too hot for each room. But due to time constraints, we were unable to.
You'll build on the idea.
Yes.
I've got a simple question.
Yeah.
So this is a low-cost product that a person would want to lower their usage of energy. I get that. What would installation look like? If me, I just go out and buy a new house, I can just run to Home Depot and buy it, or do you need an installation person to come put it in? But how easy is it to use?
You would probably need basic just hardware just to be able to mount. But the basic person should be able to do it. You just need basic hardware to actually either just mount the the vent or the vent cover over the actual vent that you have, and then obviously the hardware that we provide.
And you just run the software on your phone?
Yes.
Thank you. I have just a quick question. So what would you say the competitive advantage of this one compared to the existing smart home systems?
In this case, other smart home systems actually are quite very expensive, and they don't end up actually. So you can control.
This will be the last question we can take.
Okay. I know you can control the temperature with your smart home system, that kind of stuff. It's still very expensive, and there's other competitive companies that are selling it for $1,200, $1,800, that kind of thing, and most likely they have to be installed by an actual team of people and not separate thermostats, different things like that. I guess it's just more of a cost-effective solution, is our competitive advantage, and then also just being easily used by the person, like the customer themselves being able to install it, and so that you don't have to go through a whole ordeal. I think, yeah.
Any questions?
That was our last question.
That's all.
Okay.
Okay.
You got